All right. Oh, yeah, sorry.
No, go ahead.
Cool.
You're
Okay, 30 seconds really quickly. Can we have everyone stand up? Bring it up, bring it up, bring it up. All right, just reach up. Just really reach as high as you can. Get on your toes. Really deep stretch. Okay, bring it back. Okay, we can sit down. That's great. Okay, cool. Awesome. Now we're ready to go. So we are the out-of-school resources.
I think Joe's been having the team do calisthenics all term.
I've been trying. This is the first session that people actually stood up and did it for. All right, so we are the out-of-school resources team, and we're focused on education. Let's just jump right into it. First of all, who are we? We're a millennial team, so we have a GIF for this. We have 5 grad students, the student fellows. We have our 2 data science leads, Karen and Jose here. And then we, of course, have Sivan, our domain expert from SERPI, the Center on Reinventing Public Education. And she's focused on education research, policy analysis, knows a lot about this stuff. And what is this stuff that we're talking about? Well, let's start with a problem. The summer slide is a term for the month of education that goes straight out of students' brains over summer vacation. Now, when you think about this over the K-12 career, you imagine that we're losing a full year of education that students could have, and this means every September, teachers have to be reteaching things. And US News, this was just this past June. It's very relevant today. Luckily, summer programs can, there's evidence showing it may help reduce this summer slide. And in particular, you can look at a case study such as one done in Baltimore, which showed that students that attended an academic/arts kind of combined program, they were able to increase their performance on a standardized test by about 2% after summer vacation, versus their peers who hadn't gone to a summer program lost almost 3%. In a broader kind of, it's a 5-city bigger study, it was found that there were benefits from all types of summer programs, and furthermore, that these benefits persisted through the school year. And throughout all of this, we should keep in mind, we are talking about your nerdy kind of like math camps, your like library literacy reading groups, but we're also talking about summer programs like going out in nature and hiking, or sports leagues, or arts and crafts at your local library, these kinds of things. All are important. Unfortunately, though, not all students have access to these summer programs that can help reduce summer slide and can develop kids. In particular, this is for the summer after kindergarten. About 23% of students in a study by the US Department of Education did attend summer programs. But if you look at it split by economic level, you see that poor students had about a 7% attendance, whereas higher income had almost 40%. We can also split this up by parental education level, and we see a similar disparity. And it's well known that there is an enrichment gap between lower income and higher income kids, which goes on to lead into gaps that we see in society itself. And for reading in particular, about 2/3 of that gap is thought to come from this summer learning loss. So summer programs that can combat this kind of this summer learning loss, which contributes to this enrichment gap, will have really profound effects on society as a whole. So for this reason, we partnered with Rescale, which is a nonprofit group in Denver that focuses not only on the traditional classroom learning, but also on non-traditional learning opportunities for kids. You can see here kids learning in a lab, you can see them learning in a field, even in a mountain. They're getting lots of different opportunities to develop themselves and their minds in lots of different settings. In particular, relevantly for us, they launched just last year a Blueprint for Summer program, which specifically seeks to get access for all kids to programs during the summer.
So our driving question for this summer was looking at whether all Denver students have equal access to a variety of summer resources. So we know from what Joe was talking about that this is an equity issue in general, but we don't have very much information, and certainly not very comprehensive information, especially in the Denver context. And we've pulled together several data sources to help address this question. So the first data source comes from Blueprint for Summer, which Joe was just mentioning. This is actually a website where anyone can go to search for summer programs for their kids or anyone else you might be looking for. And we have both the data on the actual programs that appear on this website, as well as search data from users who go to the website and look for programs that they might be interested in. So this includes things ranging from the category of programs, so whether it's academic, arts, dance, etc., the distance that the program might be from a certain location, cost, and special categories like whether it accommodates students with special needs. To supplement this first data source, we also pulled data from the Denver Open Data Catalog, which is a website that is available to anyone to go to and download data. So the resources we pulled from here are parks, libraries, playgrounds, rec centers, and athletic fields. We also added museums because we know from the literature that museums have been shown to be particularly useful in helping students with their enrichment. And none of these resources correspond to formal summer programs in the way that the Blueprint for Summer website programs do, but they are things that you might expect students to be accessing during the summer, and they are definitely related to summer programs. Our third data source brings the demographics into the picture. So this is coming from the census, specifically the American Community Survey. It includes demographic information about the general population, such as median household income, race and ethnicity, education levels, age, so in particular how many people in the area are student age, 5 to 17, as well as language spoken in the home. And we have this at two levels of granularity, both the block group level, which you've already heard about, which is finer grained, and the neighborhood level, which is coarser, but a little bit more understandable to the average person. So neighborhoods in Seattle would be something like the University District or Capitol Hill or Lake City, whereas block groups are smaller regions within the neighborhoods that are a little bit harder to interpret for the average city resident. And our final data source comes from Denver Public Schools, so this gives us information about the students themselves. So we have both information such as disability status for students in Denver, as well as whether they're English language learners and other demographic information. And we were also able, for a subset of the data, to obtain approximate student locations. So these have been de-identified from student addresses for privacy reasons and come to us in the form of the census block group that the students live in. And this is important because it helps us understand the spatial distribution of different populations of students around the city.
One of the major goals of a project is to provide insights to Rescale so that they can understand how the out-of-school resources are distributed across Denver and ensure that all kids have equal access to them. So in order to be able to do that, we thought Rescale should first understand how the current resources are distributed across the city and look at this distribution from the lens of equity by taking a closer look at the demographics. And then it would be informative to understand the relationship between the supply of these resources and the demand that they have. And lastly, to have some sort of metric that would be able to measure access across the neighborhoods in Denver. So to solve this, we built an... No, that's the wrong one. Okay. Sorry about that. No, it's not connected. Awesome. Adds to my anxiety, but it's okay. So in order to solve this, we built an interactive dashboard in R, which provides certain insights and recommendations, a couple of which I'm going to talk about in the next couple of minutes. And hopefully this also gives an idea about the different features of a dashboard. So before I talk about the dashboard, I would like to remind that Blueprint for Summer website, which Kellie already mentioned, is one of our data sources. This website was used by the families of students in order to search for the programs of their choices. This search data was collected using Google Analytics and indicates the supply, indicates the demand for these resources. On the other hand, we have the existing programs in Denver, which indicates the supply. So this shows the search search tab of our dashboard. We have a couple of driving questions that helps visualize the relationship between the supply and demand. As you can see from the graph, the programs which belong to the category of academic, arts, and sports are in very high demand based upon the number of searches when compared to the programs of other categories. And the good point is that there is a very high correlation between the programs of, when we look at category-wise, between the supply and demand. And this should be very reassuring to Reschool. So moving on to the next tab, this shows the distribution of Reschool programs in Denver, and we can see that majority of the programs are concentrated in the center of Denver, which happens to be the downtown region. Now, this wouldn't have been a worrisome if only we didn't hover over one of the neighborhoods in the far right corner, which happens to be the neighborhood of Green Valley Ranch. This neighborhood has a very high concentration of students, as high as 8,500, but it has very few number of sessions, as few as in the 30s. So one of the recommendations we have to Reschool is to ensure that these programs are distributed in such a way that they correlate with the number of students present in the neighborhoods. And next, I wanted to see how free programs are distributed in the city of Denver. It follows a similar pattern where most of the programs are located in the center of Denver. In order to get more insight, I'm going to overlay the demographics information over the same map. This map shows the distribution of Hispanic population in Denver, where majority of the population is concentrated in the southwest neighborhoods. Interestingly, this region happens to have one of the lowest median household incomes and also has a very high percentage of population who have less than a high school degree. Unfortunately, this also happens to be the region with a very high concentration of students in the age group of 5 to 17. Putting this all together, we can see that the southwest neighborhoods is one of the most disadvantaged region, and we recommend Reschool have more free programs in this particular neighborhoods. So what else can Reschool do in order to solve this problem and ensure there are more programs in the neighborhoods that require them? Well, they can take leverage of the existing playgrounds, libraries, rec centers, parks, and fields in order to introduce more programs in neighborhoods that require them. For example, in this map, you can see the distribution of fields, which are pretty much equitably distributed all across the city. On the other hand, the existing sports programs are not so equitably distributed. So this is one of the recommendations we give to Reschool to take leverage of the existing programs.
All right, so this is one of our driving questions. It's my reason for waking up in the morning for the last 10 weeks. That's why I'm here now. Thank you. Naturally, to do this, we have to come up with a way to quantify access and some important way that we can measure it. So how do we do that? We use this thing that we call the access index. What does that mean? Basically, we take the distance from every block group center, and we calculate the travel time either by transit or by driving to every single program listed on the Blueprint for Summer website. We then depreciate this by a gravity-based decay function, and I won't really get into the details here, but if you're interested, we did do a whole heck of a lot of analysis to determine which decay function to use, so I'd love to take questions there. He said subtly. Anyway, we then provide separate indices for driving and for public transit, and we do this for every single cost threshold and every single type of category, and then the user in the dashboard can flexibly decide which combination of those things they want to see. We then normalize this from 0 to 100, where 0 means the worst possible access in Denver and 100 means the best. And we provide this as an average for all programs and for all free programs. If you're interested as well, this is the full equation, again, explaining how we take the sum of travel times to every single block group, and this in turn becomes the normalized score after we depreciate by the decay function. So what does this actually look like in Denver? It looks like that, where you can see that darker blue corresponds to the block groups with the highest possible access, whereas the lighter colors correspond to the lower access. In turn, with these circles, the lighter circles correspond to the areas with the largest number of sessions, while the darker circles are closer to 1 to 5 sessions. Generally speaking, you can see that access is concentrated primarily in the urban downtown area, which is sort of this central north area, as well as more of an affluent suburb, which is sort of this central southeastern location. And if you're curious, what it looks like for transit is almost exactly the same, the only difference being that access is much more sharply concentrated, this being primarily a function of the fact that transit travel times are not only longer, but grow much quicker. Returning to the overall index, we can see the more specific we get with our query for access, the more sharply located access becomes. For example, this is all programs, this is all free programs, which is only about 20% of all available programs. And if we were in turn to look at only free sports programs, we can see these are concentrated only really in one area. This is about 2% of all available programs. What does this mean with respect to the people who actually live in these areas, as opposed to just where they are? We performed some weighted correlations with student race, and we can see here on the x-axis student race, whereas on the y-axis is the correlation coefficient score. For the overall axis in general, the percent of white students in a given block group correlates to a much higher axis. We can see similarly for free programs, this flips, but again, consider that this is only 20% of programs, where the coefficient for Hispanic in turn becomes positively correlated with higher axis. We can make that very explicit. But not to be overlooked here, we should note as well that the number of black students is consistently negative correlated. And this is really a pattern that we see for every category of program at every cost threshold. For example, looking at sports programs, which is the single sharpest distribution, we see exactly the same pattern where, again, white has a very high correlation with higher access. And again, Hispanic flips when we look at free programs. And consistently, the number of black students is correlated with lower access.
So now we have our access indices that measure ease of accessibility in Denver to all of school resources. Now it is time to go back to our big question and try to answer it. Do all Denver students have equal access to a variety of summer programs? First, to answer that question, we need to identify the exact block groups that have high access and low access. Local Marin size is a statistics widely used in geospatial analysis to identify clusters with high and low values. As you can see here, block groups with high access scores and neighboring block groups with high access scores are colored in red on this map. They're clustered on the central Denver. On opposite, block groups with low access scores and neighboring block groups with low access scores are colored in blue, and they are on the outskirts of the city. So this brings us to the next question. Who live in the red areas and who live in the blue areas? In other words, if we take into account the social demographic factors like race and income, which social group is more likely to have higher access to all the school resources and which social groups are left behind? First, we know that race is unevenly distributed on the map of Denver. Here's a map that shows you what is the most common race in a given neighborhood. Just comparing the two maps side by side, it seems that the high access areas correspond well to the areas where white people are located. Here, the bar graph shows you the racial composition for the high access areas and low access areas. The bars are colored by race. As you can see, in the high access areas, the dominant race group is white people. It takes about 50% of total student population. In the low access areas, however, there is the strikingly high proportion of Hispanic students, which takes 63%. We also calculated the average access scores by racial groups and the program types. You can see across all scenarios, white students are the most advantageous, except for the free programs, where Hispanic students enjoy the highest access to. However, black students are consistently disadvantaged, and they score the lowest in all scenarios. Next, let's switch to the socio-economic factors. Here, we specifically looked at median household income for each block group and the rate of college graduates. As you can see, in the high access areas, people tend to be wealthier and better educated. This brings us to our next factor that we want to examine here. When thinking about if access is equally distributed in Denver, we need to think about the number of students in each neighborhood. Unfortunately, the reality is opposite to what we have wished for. As you can see on the map below, the gray areas shows where there are neighborhoods with more than 2,000 students. They are more on the outskirts of the city where we have identified as the low access clusters. This scatter plot shows you on the x-axis the number of students in each neighborhood, and on the y-axis, the access score for that neighborhood. Each dot represents a neighborhood. The red dots are clearly the neighborhoods we need to pay more attention to, as they have large quantities of students, yet really low access scores.
So to wrap things up, we've been able to identify key areas of the city of Denver and key demographic groups in the city of Denver with the highest and the lowest access, and we're passing these on with recommendations to Reschool and policymakers in Denver about what they can do to address these equity issues. We hope that this information can help address the summer slide, and in particular the achievement gaps that result from it, as Joe mentioned in the beginning of the presentation. And we've built this interactive dashboard that, in addition to the insights that have been presented here, will allow Reschool and other interested organizations to identify additional gaps and future trends. They understand the context in the city of Denver much better than we could hope to, so we really are looking forward to them getting to interact with this tool more and develop their own insights. In addition, we've made sure to allow for updating the slate of programs in Denver in the future. So we've built a pipeline that will allow us to bring the updated data sets with new programs, or if old programs die out, that can be incorporated, and future analysis can be done using those as well. So this won't be a static tool, it's going to live on past when we walk away in, unfortunately, just a couple of days. And some lessons learned along the way. One of the big focuses of the DSSG program and eScience in general, I believe, has been on sustainability and reproducibility of the projects. So the ability to update the data, like I just mentioned, is one of the ways that we've tried to address that. We also really hope that this can be a model for other cities where we haven't seen something like this done before. So in order to facilitate that, all of the data available to make our dashboard and do the data processing is on GitHub. The link is here if you're interested in checking that out. And we would also be happy to talk to anyone who would like to know more information about that. And finally, I just wanted to mention that it's been a real privilege to work with this group. We have a really diverse set of skills and backgrounds, both within our team, and also we've had the privilege of interacting with a lot of stakeholders outside of our team who have provided different perspectives on this work. And it's been really, really fun to put all that together and make this possible. So thank you so much to all of our sponsors and all of the people who helped make this happen. Here again is the link to our GitHub if you're interested in checking it out. Otherwise, we'd be happy to take some questions.
And questions? Into the line? Yes.
Is it necessary to model, for instance, whether it's realistic that one resident would want to go to a program that's very far away? For instance, in Seattle, if you live in White Center, it's unlikely that you would even consider an after-school program that's up in, like the north end, like MacPhee or something like that. Would that affect things, or does that just fill in with the usual accessibility figures?
Yeah, so we are actually taking that into account in our analysis by using basically the Google Maps to determine the distance between the programs and their origins. And that's also where the decay function that Andrew mentioned, but we didn't really have the time to get into, comes into account. So what happens with that is as you increase the travel time, it decays not just linearly, but actually it's a quadratic decay. So it captures that kind of effect of the farther away it is, the less likely that you would be to actually attend that program. And that's based on the gravity model, which has been used in similar analyses previously.
One of the things that I learned, I guess, today is that Denver has kind of a funny shape that I've never imagined.
For the record, it's an airport. It's like the very top right.
Yeah.
Yeah.
I mentioned that, though, because, of course, the boundary of Denver is a political boundary, right? That there are communities outside the line that have both students and schools and presumably programs that it sounds like you didn't consider because you limited yourself to Denver. And I'm curious if you had that fuller metropolitan area data set and looked at it that way, how that might change your results, or if it would, what do you think about that?
Totally. So we only have students for Denver, but we actually have programs for the entire Denver, Aurora, Boulder region. So this problem where there's programs that are right over the city line doesn't occur. we can only speak of access within Denver. We can't calculate that sort of thing for Aurora, Boulder, or the other neighbors, but yeah.
Other questions?
So could we use your tool to automatically determine, like, given a certain amount of money, where would be the optimal places to add the additional programs to attract people out?
So one stretch feature that I pushed for, but we unfortunately didn't have time to get to, was being able to put in, like, you can just kind of click on a location and you calculate kind of how access changes around the whole area. The big problem with all of this is just that every time you put in a new program, you have to calculate the distance from all of the block groups, and there's 481 of them in Denver. So it's not something you can really do in real time, but if you wanted to like run an algorithm where you just choose like some like 10 to 20 extra points that you want to try out, you can do that pretty easily. Just the way that we've written the code to add in new programs and just see how the map changes or run some insane algorithm on it. Yeah.
Yeah, basically you just add a row to the data set and then rerun the code, so it'd be very easy.
Yeah.
Any other questions?
Just curious, did you try this with any other destinations aside from schools and summer programs, like restaurants, or just to see if maybe it's a question of land use as opposed to simply educational resources?
No.
So, I mean, one point to bring up though is just Sri showed that like fields are equally distributed. Similarly, libraries are equally distributed. Like around the city. So it doesn't seem like it's just like there's like lakes or there's just like holes in populations that would totally prevent programs from coming up in those areas.
Yeah, I think similarly, when we look at the number of students as well, it's very clear that there are some neighborhoods that have both high numbers of students and high access, and vice versa, low access and low students, and then high students and low access. And so it doesn't seem to be, strictly speaking, a question of land use.
Any last questions?
Oh,
Let's.
yeah.
Oh,
I think there was one.
was there one? Oh, I'm sorry, I didn't see it. Go ahead.
I was just thinking about the summer programs, that it's a function of staff size. So how, like, are there larger programs in certain places as opposed to some programs that have smaller 10 people?
You're breaking my heart. So this is something we thought about quite a bit. I think that the preferred metric, if someone was to try to recreate this analysis, would be to take into account the size or the number of slots or the utilization of sessions. Working backwards, we have no information on utilization. About 50% of programs reported data on size, and the size varied widely. So we did do some sensitivity analysis to see for the programs that provided size, how different was the rank of the block groups based on using slots versus number of sessions. And generally speaking, the areas that are the best and worst off are the same, but the areas that fall in the middle sort of rotate pretty widely, in some cases going from like rank 50 to rank 100 or something like that. And so while ultimately I think our conclusions about identifying the best and worst off locations are consistent, that's a pretty big limitation of our analysis.
Okay, well, let's give them a last round.